Hello students, now next exercise is exercise 3.2. So in this exercise, first is graphical method of solution of a pair of linear equations. So here we will discuss about how to find solution graphically. So here first is, if the pair of lines intersect at a point. If the pair of lines intersect at a point means if two lines are intersecting at a point, then that point is the unique common solution. So here that two lines will give you unique solution and pair of equations will be consistent. So here this we will understand by one example. Here two lines are there, two equations are there. Find solutions. So x plus 3y is equals to 6 and 2x minus 3y is equals to 12. Find solution of the at least two solutions you find of this equation. Then this also you find solution. Now here you got 0, 2 and 6, 0. Now this you plot here on the graph. So here this 0 and 2, 0, 2 and 6, 0. This one, this line represent 0, 2 and 6, 0. And this line 0 minus 4 and 3 minus 2. Now you see what you observe, that here two lines, when you extend this line, so these two lines are intersecting at this point. So here both the lines are intersecting lines. So these two lines are intersecting at this point. So this point is common point. This point is common point. So this point is the solution of these two equations. So here this point means here this x is 0, 6 and y is 0. So here x is equals to 6 and y is equals to 0 is the solution of these equations graphically. This way you have to find solution graphically. What if two lines are intersecting lines, then their common point, then their common point will be the solution of that equation. So same here, if the pair of lines intersect at a point, so here both lines are intersecting at this point, then that point is the unique common solution. So here if I say what is which type of solution is this, this is unique solution. Unique means only one solution you got, that is 6, value of x is 0, 6 and y is 0. So that point is the unique common solution. And pair of equation is consistent. The pair of equation is consistent. So what is there? If lines are intersecting lines, then solution is unique and they are consistent. So this you have to learn. If lines are intersecting lines, then their common point give you the unique solution and they are consistent. Now if the pair of lines are parallel, now next type of lines are parallel lines. So parallel lines, then the equation have no solution. Which type of solution? That parallel lines will have no solution and inconsistent pair of equations. Now for example, if two equations are there, 7x minus y is equals to 42 and 3x minus y is equals to minus 6. Now this one, find solution of this equation. Find solution of 3x minus y is equals to minus 6. Now these two equations you plot here on the graph. So this line is representing 3x minus y is equals to 6 and this line is representing equation 7x minus y is equals to 42. Now what you have observed, that here these two lines are parallel lines. Here these two lines are not intersecting. So these two lines are parallel lines. So if lines are parallel, then if I say that find the solution of these two lines, so solution will be no solution, because here no point is common, no point is coming common. So here no solution. This you have to learn. If lines are parallel, then no solution. And second is lines are inconsistent. Pair of equations are inconsistent. So here if intersecting lines are there, then unique solution and pair of equations are consistent. If parallel lines, then no solution is there because no common point is there, and here inconsistent pair of equation. Now next is, if the pair of lines are coincident lines. If lines are coincident line, then the equations have infinitely many solutions. This we have to learn. If they are coincident line, then many solutions will be there and pair of equation will be consistent. So here for example, one equation is 2x plus 3y is equals to 9, another one is 4x plus 3y is equals to 9. Find solution of this equation. Find solution of this one, 4x plus 3y is equals to 9. Now this you have to plot here on the graph. So when you are plotting this first one, then it will be 0, 3 and 4.5. So here this full line will be this straight line represent first line. Now here second one is 0, 3 and 3, 1. So 0, 3 and this is 3, 1. So here means both the lines are coincident line. One line is lying on the other one. So if both the lines are coincident lines, then if lines are coincident lines, then solution will be, how many solutions will be there? Infinitely many solutions will be there. Many solutions will be there. And second, lines will be consistent. This you have to learn. Now next is, on comparing the ratios, you have to find whether the lines are intersecting lines, parallel lines, or coincident lines, or the equations, pair of equations are consistent or inconsistent. So on comparing the ratios A1 upon A2, B1 upon B2, and C1 upon C2, that now here two equations are given. X minus 2y is equals to 0, 3x plus 4y minus 20 is equals to 0. Now here ratios, now here you see, here coefficient of here x is 1, so this one will be A, and this one will be A1, this is A2. Coefficient of x will, here this one is A1, this one coefficient of x will be A2. Coefficient of y will be B1, this one B2, C1, C2. So here A1, A2, B1, B2, C1, C2. Now here, if this you have to learn, if lines are intersecting lines, then A1 upon A2 is not equals to B1 upon B2. And if lines are intersecting lines, then solution will be unique solution, and pair of equations will be consistent. So this you have to learn it. And if A1 upon A2 is equals to B1 upon B2 is equals to C1 upon C2, it means all the three ratios are equal, then you can say that the lines are coincident lines and it has infinitely many solutions, and pair of equation will be consistent. If A1 upon A2 is equals to B1 upon B2 is not equals to C1 upon C2, then lines are parallel and their solution will be no solution, and pair of equations will be inconsistent. Now you see, here A1 is 1 and here A2 is 3. So A1 upon A2 means 1 upon 3. Now B1 upon B2, B1 is minus 2 and B2 is 4. So minus 2 upon 4. And here C1 is nothing, is that means 0, and C2 is minus 20. So A1 upon A2, B1 upon B2, C1 upon C2. Now you check, A1 upon A2 is not equals to B1 upon B2, because when you will cancel it will be 1 upon 2. So now 1 upon 3 is not equals to minus 1 upon 2. So here A1 upon A2 is not equals to B1 upon B2. That's why both the lines are intersecting lines and they have unique solution, and pair of equation will be consistent. So this way you have to check whether the lines are intersecting, coincident or parallel lines, and pair of equations are consistent or inconsistent. Now here in second example you see, here A1 2, A2 4. So A1 upon A2 is 2 upon 4, and A2 is B1 minus 3, B2 is 6. So minus 3 upon 6. So here A1 upon A2 will be 2 upon 4, and here this is plus 3. So here B1 upon B2 will be 3 upon 6, and C1 upon C2 will be minus 9 upon minus 18. So when you will cancel, it will be 1 by 2. When you will cancel 3 upon 6, it will be 1 by 2. When you will cancel 9 upon 18, minus cancel, it will be 1 by 2. So here all the ratios are coming equal. A1 upon A2 is equals to B1 upon B2 is equals to C1 upon C2. So if all the ratios are equal, then you can say that lines are coincident lines. It means infinitely many solutions, and it is a pair of equations are inconsistent. Now next is x plus 2y minus 4 is equals to 0, and 2x plus 4y minus 12 is equals to 0. Now here you see A1 is 1, so A1 upon A2 means 1 upon 2, B1 upon B2 is 2 upon 4, and C1 upon C2 is minus 4 upon minus 12. Now here 1 by 2, this also 1 by 2, and here it will be minus cancel, it will be 1 upon 3. So here this A1 upon A2 and B1 upon B2 both are 1 by 2, 1 by 2. But C1 upon C2 is 1 by 3. It means A1 upon A2 and B1 upon B2 are equal, but C1 upon C2 is not equal. So if A1 upon A2 is equals to B1 upon B2 is not equals to C1 upon C2, then lines are parallel. If lines are parallel, then no solution. If no solution, then pair of lines will be inconsistent. Now next question is, here two equations are given, these two equations and these two equations. By these two equations you have to check whether the lines are intersecting, parallel or coincident, and it is pair of equation are consistent or inconsistent. So here you see, this is this one a1 upon this one 4 upon 3x plus 2y is equals to 8. This is a, b and c. So here a, b and c. So here you see 2x plus 3y minus 12 is equals to 0, and here it is 4 upon 3x plus 2y is equals to 8. So this also you change into same form. So minus 12 this side you convert, it will be minus 12 this side you transpose, it will be positive 12. So now here both are in same form. This one a1 a2, b1 b2, c1 c2. Now a1 upon a2 means 4 upon 3 upon 2. Upon 2 nothing is there, it means 1. So 1 into 4 upon 3 into 1 into 4 upon 3 into 2. So that is 4 upon 6. When you will cancel 2 upon 3. b1 upon b2 means 2 upon 3. And c1 upon c2 means 8 upon 12. Because minus 12 this side you transpose, it will be 12. So 8 upon 12 it will be 2 by 3. So here what you have observed, that a1 upon a2 and b1 upon b2 and c1 upon c2 all are equal, that is 2 upon 3. If all the a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2, then it means that pair of linear equation is consistent and the lines are coincident. If all the three ratios are equal, then lines are coincident, and if lines are coincident, then the pair of equation is consistent. Given the linear equation 2x plus 3y minus 8 is equals to 0, write another linear equation. Here one equation is given to you, one linear equation is given to you. You have to write another linear equation such that the geometrical representation of the pair so formed is intersecting, parallel and coincident. Then what is the question? Here one linear equation is given. You have to write another linear equation so that both the lines are intersecting lines, both the lines are parallel lines, and both the lines are coincident lines. Now your first is intersecting lines. If the lines are intersecting lines, one equation is given to you, you have to write another equation. So if lines are intersecting lines, then it means a1 upon a2 is not equals to b1 upon b2. So here a1 is 2, then a2, and means answer can vary here in this. So here I have taken here as 5. So here a1 upon a2 is 2 upon 5, b1 upon b2, any number you can write. Here b1 upon b2 3 upon 2. So here a1 upon a2 is not equals to b1 upon b2, and here c1 is minus 8 and c2 I have taken minus 9. So here you see a1 upon a2 is not equals to b1 upon b2. So you can say that both the lines are intersecting lines. Now parallel lines, given equation is 2x plus 3y minus 8 is equals to 0. If lines are parallel lines, it means a1 upon a2 is equals to b1 upon b2 is not equals to c1 upon c2. So here a1 is 2 and b1 I have taken as, a2 I have taken as 4. That is 1 by 2. Now here 3. So here I have taken as 6, because when you will cancel it will be 1 by 2. So a1 upon a2 is equals to b1 upon b2, but not equals to c1 upon c2. So here c1 minus 8. So here I have taken as minus 3. So here a1 upon a2 is equals to b1 upon b2, but not equals to c1 upon c2. So here 4, this 4x, here this 6y minus 3. So here this is first equation, this is second equation. Now here coincident lines means given equation is this one, you have to write another equation. So here a1 upon a2 is equals to b1 upon b2 is equals to c1 upon c2. This is the condition for coincident lines. So here a1 upon a2, a1 is 2, a2 I have taken as 6. So when you will cancel, it will be 1 by 3. Now here b1 is 3, b2 is 9. When you will cancel, it will be 1 by 3. Here c1 I have taken as minus 8 and c2 here as minus 24. When you will cancel, it will be 1 by 3. So here you see a1 upon a2 is equals to b1 upon b2 is equals to c1 upon c2, because in all the three 1 by 3, 1 by 3, 1 by 3. So here this one is 6x, 9x minus 24. So here another equation is 6x plus 9x minus 24, because coincident lines are there. It means a1 upon a2 is equals to b1 upon b2 is equals to c1 upon c2.